In the figure below, points A, C, and E are collinear. So A, C, and E are collinear. That means this right here is a segment because all three of these points lie on the same line. And B, C, and D are collinear. That means B, C, and D are also on the same line. So these are also collinear. That means BD is a segment that contains point C. And AE is a segment that contains point C. Angle measures and side lengths are as marked. So we have to use the ones that are given over here. And it tells us that AB and ED are parallel. So AB and ED are parallel. Let's go ahead and indicate that right over here. And then it asks us, what is the length of ED? So it's asking us for the length of this side right over here. We want to know what that side length is. So first things first, let's go ahead and try and label all of our angles if we can. And that's going to look like this. So we know that this is 140. That means when subtracted from 180, this angle must be equal to 40 degrees. If this angle is equal to 40 degrees and this angle is equal to 60 degrees, collectively they are equal to 100 degrees. And since the inside angles of a triangle add up to 180 degrees, this must be 80 degrees, just like that. And we can also go about figuring out the other side, and we also can determine that this is also 40 degrees by the same principle. And in addition to that, because we know that these two lines are parallel, so I'll go ahead and see if I can extend this out a little bit, right there and right there. Just a little bit, just so we have a visual on what's going on. We can see that this angle right over here, angle B, is an alternate interior angle to angle D right over here because these two lines are parallel. So that means angle D and angle B must have the same angle measure, and that's going to be 80 degrees. And the same can be said about angle A and angle E. They are alternate interior angles, therefore this is 60 degrees. So we have established that the angle measures of the inside of both of these triangles are exactly the same. That means the triangles are similar. So we know that triangle ABC is similar to triangle CDE. And now we can go about figuring out what's going on. Okay, so if the triangles are similar, that means the ratios of the sides of the triangle must be proportional. So we know that AB over its corresponding side, which is DE, is proportional to, must be equal to, so this proportion right here must be equal to BC over CD, and this must be proportional to AC over CE. So if we have any two of these, we can determine all of them. Unfortunately, it does not give us two segment measurements. It only gives us one segment measurement, which is this 3 right over here. It does not give us a corresponding measure of this segment over here. So there's no way for us to figure out what that proportion is and then extrapolate that to give us the correct answer. It doesn't give us the measurement for any of these sides. So all we can say with confidence is that these two triangles have the same internal angles and that they are similar, but we don't know we don't know the proportion of the lengths of the sides. And so, for example, this, if we draw this a little more straightened up, these two triangles could look like this. It could be here and here. It could look like that. Or it could look like this. It could look like the other way. It could look like this and like this. In each of these cases, assuming these are segments, and you'll have to excuse my terrible drawing, but in this case, this triangle is similar to this triangle, and this triangle is similar to that triangle, by the same properties that we saw here. Unfortunately, we have no way of telling which side is the bigger one and what that proportion is. So in this case, the correct answer is actually E. It actually cannot be determined by the information provided to us in this problem. Therefore, our answer is E for elephant.